Hello everyone. Uh, Hope all of you are able to see the screen, right?
Yes, ma'am.
For this session, I know all of you know, I hope all of you will know that we will going to revise the calculus portion.
Yes, ma'am.
So let's start with it. So we will start from the sequences. So last day I discussed about functions, right? So all of you know what is function, right?
Yes, ma'am.
And how can we define sequence then? It's a particular case of function, right?
Yes, ma'am.
Yes, ma'am.
So in order to define sequence, particularly we take our domain as natural number, right? So a function from natural number to real number is called sequence, right?
Yes, ma'am.
Yes. Okay. So then we covered the topic, the concepts of subsequence, right? Subsequence. So we can define a sequence as n, right? And what is the n? It's the image of the element n, right? So n belongs to natural number. Then f of n is basically n, right? And what is this set? It's basically the range set of f, right? Collection of all the images under the map f, right? Then if we have a set, obviously we can define subsets. So subsequence was nothing but subset of the sequence or the range set of f, right?
Yeah, ma'am.
One more result, we know that if n is a sequence, okay, let us talk about limit first. So if we have a sequence, then we can define the limit of the sequence, right?
Yes, ma'am.
Yeah. So if we have a sequence an, then if an tending to a as n tending to infinity, then we will say that a is limit of the sequence. So graphically, what we can do, if it is our Cartesian coordinate, this is our a, then when n tends to, suppose this is the natural number, so when n tends to infinity, the sequence may be something like that, tending to a. Okay? Or it may be something like that, tending to a. That means when n will tend to infinity, the sequence will tend to the point a. The functional value will tend to the point a. Okay? So if for a sequence, if finite limit exists, if a is finite, then we know that the sequence is called convergent sequence, right? Then an is,
Yes, ma'am.
yeah, then an is convergent sequence. Otherwise, we will call an as divergent sequence, right? Otherwise, an is divergent.
Ma'am, like the finite exam, like this convergent and divergent, can you please give an example of it?
Yeah, sure. So suppose we have a function from n to r such that x is n is going to 1 by n. Okay. Then as
Yes,
n
ma'am.
tends to infinity, 1 by n will be tending to 0, right?
Right, ma'am.
That means this is a finite number, right? In
Okay.
this case, we can say the sequence is convergent. Now we can define another function from n to r such that n is going to n square. So in that case, when n will be tending to infinity, n square will be again tending to infinity, right? This is not a finite number, right?
Yes, ma'am.
Yes,
Now
ma'am.
got it.
So this sequence is divergent. Okay.
Okay. Yes, ma'am.
So we can we have another one case, like suppose if n goes to -1 to the power n. Okay. Then we will get two types of term, right? When n is even, we will get 1. And when n is odd, we will get -1, right? So the sequence, the range space will be something like 1, -1, 1, -1, and so on, right? In this case, we can note that the sequence is not a convergent sequence because as n tending to infinity, we cannot determine whether the functional term will be tending to 1 or -1, right? So this is
Yes, ma'am.
another example for a divergent sequence. So this was an example of a convergent sequence and divergent sequence. So you can solve some easy example. Suppose if it is from n square plus 2n 3 over 7 n cube. Okay. Then what will be the limit? Whether the sequence is convergent or it is divergent or what? Yeah, this concept is enough if you understand the concept properly. And based on this concept, you have to solve some problem. Then it is enough for this term. Okay.
Ma'am, this is going to be divergent, right?
Okay. I will wait for some other answer. Then we will do it together. Okay. What you have to check? You have to check as limit n tending to infinity. What is the value of Fn?
In the denominator, it is n cube or 3n, ma'am. I mean n3.
Yeah, it's n cube.
Okay.
It is divergent. If everyone is saying it's divergent, what would I suggest that you should look at the power. Okay, the power here is lesser than the power in the denominator, right? So it should not be divergent. With the single loop,
Convergence, ma'am. Actually, n square by n cube, 2n by n cube plus 3 by n cube. If you will put infinity, then it should come 0 on that.
yes, yes. So this is a simple observation. Okay. So if you have something like that, we can separate it, right? Then it will
Answer
be,
is 0.
yeah, then 3 by n cube, right? So as n tending to infinity, 1 by n tending to 0, right? This will be 0. So the sequence is convergent. Okay.
Ma'am, what if we take this n square common from both numerator and denominator and then we apply limits?
So you can cut it down, right? After taking
Yes,
it
ma'am. Yes, ma'am. That's
common.
what I'm saying.
Yeah. So this is the same thing ultimately.
But ma'am, it'll leave us 1 by n, and that 1 by n will be 1 by infinite.
Okay, okay. Let us do same thing. So if we take n as common, n square as common, then we
N
will
square.
have 1 plus 2 by n plus 3 by n square, right?
Yes, ma'am.
And there will be n cube. Okay. So you can cut it down, then it will be this. So it is 1 by 2 by n plus 3 by n square by n, right?
Right, ma'am.
So as we go, as we n tending to infinity, then it will be 1 plus 0 plus 0 by infinity. So it is 1 by infinity, right? Which is 0.
Yes.
Clear?
Oh, okay, ma'am. Actually, I was considering this 1 by infinite as. Okay, ma'am, got it.
Ma'am, is it so that if the degree of the leading term of numerator is greater than the degree of the leading term of denominator, then it is convergent?
If the leading degree of the leading term in the numerator is lesser, then the sequence will be convergent. Okay. If it is greater, then the sequence will be divergent.
Numerator or denominator, ma'am?
Numerator.
If numerator is greater, it will be divergent because we will have n in the numerator, and it will
If
tend
it
to
is
infinity.
greater, then it will then the sequence will be divergent. Okay. If this is lesser, then the sequence will be convergent. Okay.
Okay.
Ma'am, I have a doubt, ma'am. Actually, for convergent, limit n to infinity. When we get 0, then it's convergent, ma'am.
Not 0. We can get, if we get any finite real number, then we can say it is convergent. Okay.
Okay. Thank you, ma'am.
So that if we define a function fn 1 plus 1 by n, okay, then as n tends to infinity, this function will be tending to 1, right? So this is again one convergent sequence. Okay. This limit should be any finite number, not necessarily 0. Okay.
Okay, ma'am. Thank you, ma'am.
Excuse me, ma'am, 1 by infinity is equal to 0.
Yeah. I cannot hear you.
Ma'am, can we common out NQ instead of N square?
No, there is no n cube here, right? We can, if you want to common n cube, then it will be same case as this, right? Ultimately, we are doing same here. If you take n cube from this portion, then it will be this term, right? This term. So far, is it clear to all of you?
Yes, ma'am.
Yes, ma'am, understood.
Yeah. So let us solve on another example. Suppose n tends to infinity, we have some 7 n square plus n over sorry, n square plus 1. Okay. So what will be the limit then?
7.
So everyone is agreed with it?
Yes, ma'am.
Yeah. It's clearly 7, right?
Yes,
We
ma'am.
get square as common, then we will get. Okay. So yeah, if you have any doubt from the sequence portion with any exercise, you can let me know. Okay. Otherwise, we will go to the limit of a function. Okay.
Ma'am, is this theory revision session?
We can solve problem also. I will solve some problem, 2 to 3 problem. If you have doubt, you can ask. Otherwise, we will also revise the theory portion.
Yes, ma'am, this is also the best way to understand anything.
Yeah.
Yeah, thank you, ma'am.
We
How
are not
this
going to
thing
cover
7, ma'am, in this
anything
one?
here. Okay.
Ma'am, we cover only the important section.
No, I would like to cover a maximum portion, like the whole calculus portion. So I think all the concepts are important.
Yes, ma'am.
Ma'am.
Ma'am, how it is 7, ma'am? Can you explain, ma'am, once?
What? One by one, please. Otherwise, I'm not able to hear you properly.
How it is 7? Can you explain once? Just forgot.
You can take m square as common. Then it will be 7 plus 8 by n, 1 plus 1 by
Oh,
m.
okay. Thanks.
Okay. So I guess you don't have any doubt with the sequence thing. If you have, then you can take a screenshot of this problem, of this particular problem, and you can post it on the chat box. We can solve it together, okay? So, let us. Sorry, we cannot hear you. I think there is a network issue. So, yeah, we can write your doubt in the chat box, okay? So, what was limit of a function?
Hello, ma'am.
Yeah.
Ma'am, can you please scroll up from when you started?
I just defined sequence thing, basic sequence things, and then we solved two problems, okay? The basic simple problem. If you joined just now, we can find the video on the YouTube channel, okay? You can have a look.
Okay, ma'am. Thank you, ma'am.
Yeah. So let us discuss about the limit of a function. So anyone can unmute yourself and tell me what was the difference between limit of a sequence and limit of a function. For a function, we will take some general function, right? Where AB is a subset
ma'am.
of R, right?
Yes, ma'am.
This is a general case. So sequences, limit of a sequence is basically a particular case of limit of a function, right?
In limit of a sequence, we use n tends to infinity, but in functions, we can use various things.
Any
Yeah, x tends to
any
0,
real
x
number.
tends to 1,
Yeah.
anything.
Yeah, right.
Ma'am,
So that is
if we
the
put
main difference.
input limit, ma'am, if we put input, then function value goes to some some limit. This is called the limit of function, I think.
Yeah, right. So when we're talking about limit of a sequence, we're not bothered about at which point we want to determine the limit, right? Because for sequence, it was fixed. It was n was always going to infinity, right? But here
Yes, ma'am.
we have another extra term, which is x equals to a, right? So if fx tending to L, when x tending to a, okay, then we would call that the function is the limit of the function f is L at the point x, right?
Yes, ma'am.
Limit of f is L at x. So here at x equals to a. So here we have this new term. That's it. Nothing more than that. Okay. So we did.
Ma'am,
Yeah.
can you please explain the difference again?
Okay. So limit of a function and limit of a sequence is basically same. Limit of a sequence is a particular case of limit of a function. In case of limit of a sequence, our n was only tending to infinity. But here we can take any real number and infinity also. Okay. So here we are doing this new thing. Nothing more than that. Okay.
Ma'am, for function, we can take it can tend to infinity, right? That's what you're saying.
Yeah. Yeah.
Also,
Can
we
tend
don't
to
have the
infinity.
constraint.
It can tend to like any real number. For the sequence case, there was only infinity, which we are looking for. But here we have any real number and infinity. Okay.
Okay, ma'am.
Also, we don't have the constraints of the domain, right? For that sequence part we
No,
had
you
from
don't need to think about the domain, because here we are defining a general function. General function
okay.
for any subset of R. Okay. And in the case of sequence, we are taking just a particular case, which is natural. So that is how we were defining the function. So this was limit. Now let us solve some example. Suppose a limit extending to 1 by 1 minus x minus 3 by 1 minus x. Yeah. Let's solve it. Let me know what is the limit. Okay, I got one answer as 0. Let others solve. 0 is 0. Okay. Let us solve it together. Okay. So here our limit is extending to 1, right? And as extending to 1, this term and this term will tend to 0, right? So we have a problem here. Now, what we have to do? We have
Cross
to,
multiplication.
yeah. And we can arrange the term in such a way such that this term, we can remove this term 1 minus x, right? This is our aim to remove the term 1 minus x, right? So what we can do, we can simply take 1 minus x and we have aq minus bq formula, right?
Yes, ma'am.
Yeah,
We
ma'am.
break it, this formula. So it will be 1 plus x square, right?
Yeah.
Yes, ma'am.
Yeah. So we can take 1 minus x as common. Okay. So it will be 1 plus x squared minus 3 by 1 plus x squared. Okay. To 1 by 1 minus x. So it is x squared plus x minus 2 over 1 plus x squared. Now we can factorize this term, right? So I guess you can, all of you can do that. So it will be x minus 1, x minus 2 plus 2. Fine. So we
Ma'am,
can
is it
simply
minus 3? I mean, in the previous line.
yeah. So there is plus 1 minus 3, right? So it's
Oh,
minus.
sorry, that's that.
Yeah. So we can arrange this term as
Ma'am, how we get it, ma'am?
Yeah, I'm doing this. Plus 2x minus 2, right? We can rearrange this term. Then we can take x common. Then it will be x minus 1 plus 2 as common, then x minus 1. So it will be x minus 1 plus x plus 2. Okay?
Yeah, okay, ma'am.
Okay, ma'am.
Yeah. Then we can cancel this 2 term out, right? So there will be 1 minus and extending to 1, x plus 2 over 1 plus x square, right? Now we don't have any kind of disturbance here. So we can directly put 1 instead of x, right? So it will be 1 plus 2 over 1 plus 1
Ma'am,
plus
it is x minus 1 and divided by 1 minus x. How have you cancelled out?
I just take common this factor 1 minus x. You have to apply the formula for aq minus bq. Okay.
Yes,
Ma'am, he is asking that is a 1 minus x and you are cancelling x minus 1.
I'm
I
taking
get-
minus 1 outside, right?
Yes,
Okay,
ma'am.
okay.
That's where this minus came up.
Yes.
Okay,
Right.
okay. Okay, ma'am.
So it will be minus 1. It's fine.
Yes, ma'am. Right.
Yes, ma'am.
So it's clear to all of you, right?
Yes, ma'am. Yes.
Yes, ma'am.
And it's roll upward side.
So let us look at the next example. For now, suppose we don't have any formula. Okay, let me first tell about L'Hopital rule. You all know Still, I'm just repeating it because it's a revision session. L'Hopital rules is saying that if we have some limit tending to some a, fx by gx in the indeterminate form, that means if it is 0 by 0 plus minus infinity by some plus minus infinity, if it is in some of this form, then this limit will be equal to extending to a f dash x over g dash h, right? All of you are aware about this form. Okay, so in the next exercise, you have to apply the L'Hopital rule. This is a hint for you. For now, let us assume there is no formula. Just try to solve this one. Okay, f of x equals to 1 plus 7 by 3x power x. This is your function. You have to calculate the limit as extending to infinity. Take your time, 2 to 3 minutes maximum. Try to solve it. Okay.
What is the question here?
What?
What is the question? What is the question here?
You have to find the limit of the function as extending to infinity.
Ma'am, here we can use monkey theorem. Like,
you have to use the L'Hopital rule here. This is a hint for you. Here we have x in the power. This is our x in the power. Okay. So what we can do? We already solved this type of problem, right? In the previous lectures. So try to use the logarithmic function and try to do some conclusion.
And we can use logarithm functions on both sides.
Yeah. So this is the hint. You can use logarithmic function and you have to use the L'Hopital rule. Now to solve the problem and let me know the answer. Okay.
खराब खराब तुमको तो मिलिया वो कार उतरा तो है खराब है और पक्का देखा तुम नमस्कार किया
Okay, I got some answer. One is 1 and another is
Answer is 1, ma'am.
1 and e power 7 by 3. So let us see what is the answer. Okay. First of all, what can we do? We have f equals to 1 plus 7 by 3x or x, right? So we can take log both sides. So log of x will be log of this function, right? 1 plus 7 by 3x, okay, power x. So you can take x here. Then it will be x into log of 1 plus 3x, right? Then we want to apply the limit. Limit extending to infinity, log of fx equals to limit extending to infinity, x log 1 plus 7 by 3x. Okay. So when extending to infinity, this term will be tending to 0, right? And log of 1 is 0. So here for this term we have 0, and for this term we have infinity. So 0 into infinity is not a valid multiplication, right? So what we have to do, we have to change the function, and we have to adjust the function in such a way so that it will get some form. Okay. So what we can do, we can limit extends to infinity log 1 plus 7 by 3x over 1 by x. Okay. So this is the same basically, right? This is same, right?
Yes, ma'am.
Yeah. So now we can see that it is in 0 by 0 form, right? As x tends to infinity, the upper one will be tending to log 1, which is 0. And if extending to infinity, 1 by x tending to 0, right? So now our function is in 0 by 0 form. So now we can apply the L'Hopital rule or L'Hospital rule. Okay. Simply
Ma'am,
we will
how have you written 1 by x in denominator? Can you explain that?
1 by 1 by x means x, right? That's a
Okay.
simple step, right?
Okay, ma'am.
Yeah. So we have to do the derivative here. So what is derivative for log x? Is 1 by x, right? 7 by 3x. Now again we have to derive this thing. So which is 7 by 3 into minus 1 by x square, right? And what is derivation for minus 1 by x? It is again minus 1 by x square, right? So you can note that this minus 1 by x square and minus 1 by x square will be cancelled out, right? So our function became 7 over 3 limit extending to infinity 1 by 1 plus 7 by 3x. Okay. So we can directly put infinity instead of x, then it will be, this term will be 1, right? So the limit will be 7 by 3. Fine. So limit extending to infinity fx will be e power 7 by 3. So is it fine for all of you? Are you comfortable with the
Ma'am, how
solution?
this 1 minus x
This
square
step,
came, ma'am?
What?
Ma'am, in the denominator,
Yes.
1 by x square came, ma'am.
Minus 1 by x square, right?
Yes,
Because we have to do the derivative.
we have
Ma'am, before divide to the power 1 by x, if you will, why you can't apply that fx into gx formula in that part?
Because it's infinity into 0, right? Infinity into 0 is not a valid term.
Okay,
It is not a defined one, right?
Mom, here in
Yeah.
the second step, limit extends to infinity 1 by 1 plus 7 by 3x. You're differentiating the term, right? The entire term.
Logarithmic function.
Logarithmic function.
Yes. We have to
Ma'am.
apply the chain rule here, right? If we have log x, differentiation of log x is 1 by x, right?
Yes, ma'am.
1 by
And
x.
if we have some function instead of x, then we have to do the differentiation again, right? Just we are applying the chain rule here. Okay? It's fine.
Ma'am, I have one doubt. How the negative 1 by x square in the numerator, ma'am?
Because we are doing the differentiation with 1 by x. Differentiation of 1 by x is what?
Ma'am, can you please quickly summarize this question?
What?
Ma'am, quickly explain this question. Yes, ma'am, this one.
Ma'am, I had a doubt.
Yes.
Ma'am, when we are differentiating the RHS, won't we differentiate the LHS as well?
No, because here we want to determine the limit, right? We are not differentiating both the side. Here we are applying L'Hospital rule. Because this is in 0 by 0 form, the limit will be same as the limit of the determinant function.
Yes. Okay. Got it. Thank you.
Yeah, so we have a function here. Let me do a quick, did we call it? So we have a function
Ma'am,
here. Yeah.
ma'am, is this chain rule or product rule?
Chain rule is, no, this is chain rule. This is not product.
In second last step.
Okay, ma'am.
It's chain rule. Okay. So
Okay,
all
ma'am.
of you are about the chain rule, right? It was part of your 12th syllabus.
Yes, ma'am.
Yeah.
Yes, ma'am.
Okay. So
Ma'am,
we did
3 seconds.
nothing new. All of this concept are already, like, you all know already this, all the concepts. Okay.
Ma'am, is
So
it log? Ma'am, is it log f of x is equal to 7/3 or limit only f of x is
yeah,
equal to
yeah,
7/3?
log limit extending to infinity log f of x is 7/3. Then we can take log outside and it will be e power 7/3.
Oh, okay, ma'am. Okay, ma'am.
Yeah. Log and limit is interchangeable because logarithmic is a continuous function. Okay. So if we have a continuous
Okay, ma'am.
function, then only we can interchange the limit and the function. If we don't have any continuous function, then we cannot do it, right?
Yes, ma'am. Okay, ma'am.
Ma'am, can you please explain how -1/n square has come, ma'am? Please, ma'am.
It's just a derivative of 1/x. You should know the derivative things, right? I'm doing nothing. I'm just applying El Hospital rule here. Derivative of 1/x is -1/x.
And how this 7/3 came?
Fine.
And how this 7/3
Yes, ma'am,
came?
clear.
7/3 is the constant multiplication was with 1/x, right? So what I would suggest you, please check with the derivative formula. Just like practice it. You will be like more comfortable with it. Okay. So let us start with continuity. Okay. So what is the thing for continuity? First condition that if we are defining the limit, when we are defining the limit at some point x equals to a, then the a was not necessarily in the domain, right? We can define limit for a function which is at some point which is in which doesn't belongs to the domain, right? But for continuity, is it possible to do so? Is it possible?
No, ma'am.
No, ma'am.
So first condition should be the point should be in the domain of the function, right? It was a first condition. The point have to be in the domain of the function. Then only we can comment about continuity of the function at that point. Okay. And the second thing was limit equals to f of x. It was the definition for continuity, right? So it's a simple concept. If if a were not in the domain, then we cannot define f of a. Maybe f of a may not be defined, right? So a should be in the domain. So this was the first condition and this is the second condition. That means limit extending to a, f of x equals to f of a, right? If this happens, then we will say that the function is continuous at the point x equals to a. Okay.
Can you repeat second condition?
These two are conditions. This is first condition and this is second condition. So this is the condition. So the function is continuous at a if and only this happens. Okay. Okay. So quick remark. You already know that continuity implies limit, right? That means at a point, if the function is continuous, then the limit of the function will exist at that point, right? Because
Yes,
here
ma'am.
L exists and L is particularly f of x. Okay. So let us solve one problem. Suppose our function is minus x squared by 2 when x less than 1, 3 when x equals to minus 1, and x squared plus 2x plus 3 when x is greater than x. So what you have to check, we don't have any problem with other points, right? So we have to check that whether the function is continuous at x equals to 1 minus 1, whether the limit exists or not. So this is your task. Please do it.
Does not exist.
No, it is not continuous.
It is
Limit
not
even does not
continuous.
exist.
Yeah, it does not exist.
So what is
Because
the left
RHL
It's
is,
discontinuous.
because LHL
what
does
is
not
the
equal
left
to
limit
RHL.
here?
Minus 3.
Minus 3.
Minus 3, right? What is the right hand limit here?
0.
It's
It's 1. It's
Plus
1.
1 it is.
1
One.
minus 2 plus 3, right?
Is
Yeah,
2.
ma'am.
That means 2. Okay. So clearly these are not equal. So limit doesn't exist. If limit doesn't exist, then obviously the function is not a continuous one. Fine. Let us consider second example. Suppose f of x equals to 1 by x plus 2, x plus 3, when x is greater than some 1. Minus 1 and 1 by some x minus 4, suppose, and x is equals to minus 1. So the function is defined in this domain, right?
Yes, ma'am. Function is defined.
Okay, so we don't have any problem. So let us now check whether the function is continuous at minus 1 or not.
Not continuous.
Yeah, it is not continuous.
Is the limit exist? What is the left hand limit?
1 by 2.
So we can directly put the value here, right? So it will
Minus
be
1 by 6.
1 into 2. So it is 1 by 2. So, and right hand
No,
limit?
it is right hand limit.
Right hand limit only 1 by 2, ma'am. Sorry.
Second one, 1 by x
Sorry,
minus 5
it is right hand limit. Yeah.
Yeah.
It is right hand
Yes,
limit.
ma'am.
And what is
Minus
the
1
left hand
plus.
limit? Minus 1 minus 5,
One
right?
Minus 1
Yeah.
minus
Minus 1 by 6.
1 by 6. Yeah.
So limit doesn't exist, hence the function is clearly not continuous. Okay. Yeah. So what was next? The differentiability concept, right? So we'll say that suppose we have a function f from some a to real number, then we will say that f is differentiable at a if limit h tends to 0, f of a plus h minus f of a by h exists finitely, right? Right? It was the definition, it was condition for differentiability. Right? All of you know that. Okay. So if we have a function which is differentiable, then we will denote this limit as f dash a, right? And this f dash a, we were calling this f dash a as derivative of the function f, right? It was the derivative of f at x equals to a. Okay. And we have, if we have the derivative of the function, then we know the equation of a tangent, right? Which was fx into x minus a, f dash a plus f of a. It was the equation for a tangent, right? Of f at the point a. So sometimes we call it as the linear approximation of the function a near of the function f near a, right? So if we have a function like that, suppose this is our point a and this is the tangent at the point a, right? Tangent meant it was just touching the curve at that point, right? So in some close neighborhood of a, these are same, almost same, tending to the same thing, right? So
Yes,
that is
ma'am.
what, yeah. So we call the tangent as a linear approximation of the function a near a, okay? In
Yes.
some close neighborhood of a. Okay. So suppose we have a function x sin x when sin x by x when x not equals to 0 and 1 when x equals to 0. So is a function differentiable at x equals to 0. You have to check whether the function is differentiable at x equals to 0.
Yeah, it is differentiable.
So we can check via the so clearly we know the limit and continuity will be same, right? Like the limit and the function is limit exists for the function and the function is continuous, right? So we'll check the whether it is differentiable or not. So we are checking at the point 0, so it will be this, right? So limit is tending to 0, sin h by h minus 1 by h, right? So limit h tending to 0, sin h minus h by h square, right? So it is in 0 by 0 form. So what we can do, we can apply the L'Hopital rule here. So it will be cos h minus 1 by 2h, right? Which is again 0 by 0. Because cos 0 is 1. So 1 minus 1 is 0 and we have h. So we can again do the derivative. Then it will be sin h by 2, right? Now we can directly put 0 instead of h. Then we will get 0. Okay? Which is a finite limit, right? That means at the point 0, the derivative exists for the function and f dash 0 is equals to 0, right? Then what is the equation of the tangent? What is the equation of the tangent?
F of a plus x minus a into f dash a.
Yeah, so it
F
was
dash a plus f of x a plus f of a.
right. It was for plus or minus. I forgot. Yeah, it was plus.
There is plus.
Yeah, we can directly put the value. Then it will be 1, right?
Yes.
Ma'am, I have a doubt. In differentiation, it doesn't need to be equal to x is not equal to 0 sin x by x. That should not be, not must be equal to 1. It should be, the answer should be in a finite manner, like that.
We just need a finite limit of this particular limit, okay? We just need a finite limit. This need not be equal to that f of 0 things, okay? Here we don't have in that kind of concept. Okay, so yeah, I think it was you're up to week 8. So if you
What
have
can we
any,
expect from the questions like from linear approximation?
Yes, ma'am, I have doubt in this tangent equation, that is linear approximation equation.
so the thing is, if we have the function which is differentiable, then we can find the derivative, and using the derivative we can calculate the equation of a tangent, right? And the equation of a tangent is nothing but the linear approximation of the function at that point. Okay, so we have given the equation. Now if we have any doubt with this, with any particular problem, I would suggest you to take the screenshot and post it on the chat box so that we can solve it together. Okay.
Ma'am, I posted one question in the chat box, so if you could take it.
Because I can see one question.
Yes,
The
ma'am.
question is, fx equals to, is this one which you are talking about?
Yes, ma'am, exactly this one.
Then we have to find the limit when extending to 4, fx minus f of 4 by x minus 4. So what we can check, we have problem with this factor, right? As extending to 4, this factor will be tending to 0. So we have some problem with this factor. We can directly put the value here. Let's now then check what is going on here. So extending to 4, 1 by x minus 1 minus root x minus 1 by root over 4 minus 1 minus 4, right? Over.
Yes, ma'am.
So this is our function. For this function, we have to check the limit. Okay. So if we have something in root format, what should come to our mind first? We should do the conjugate thing, right?
Yeah, rationalize.
We will
Rationalize the word.
multiply both the with this term. Then we will get x minus 1 minus x minus root 3 plus 2 over 3 minus 1. 3 minus 2, right? And then
Yes, ma'am, right.
okay, this term will be cancelled out. And this is 1. This is 1. Okay. So we'll have limit extending to 4 root over x minus 1 plus root x minus, here will be 1 minus, minus root 3 minus 2 over x minus 4. Okay. Now we can check if we directly put 4 instead of here. Here if we directly put 4, then
4 minus 1.
So is it?
I'm 0 by 0 will be there, I guess. No.
No.
No, I'm not 0 by 0.
Oh, sorry. It should be 4.
It is 0 by 0.
I'm sorry. It should be 4 here. Okay.
It will be 2, ma'am.
It is 2, but here it should be 4, right? So it will be minus 1. It will be plus. Okay. It's fine.
Yes,
because we are doing a square plus b square, right? So we have to take 2 square.
So now it's 0 by 0.
Yeah, now it's in 0 by 0 form. So we can apply the L'Hopital rule here. So what will be the derivative? What is derivative for root over x?
1 upon 2 root x minus 1.
Minus x minus 1 power minus half, right?
Yes, ma'am.
And for this, we have minus 1 upon 2 x power minus half, right? For this portion, we have 0 and here we have 1, right? So now we can directly put the value here. So it will be 1 by 2, 4 minus 1 power minus half minus 1 by 2, 4 power minus half, right? Now we can simplify it and calculate the value.
Okay, ma'am, got it. Yes, ma'am. Ma'am, can you just zoom out? I want to take the screenshot.
Madam, can you go above the first step? Ma'am, little bit doubt. The first step. Question is given.
Yeah.
Thank you, ma'am.
Question is given f of x minus f of 4.
Yes.
I thought that why in above we did minus.
Yeah, in the question it was given. So it's clear, right? It's clear for
Yes,
all
ma'am.
of you. Let me just briefly describe about the Riemannian integration concept. Then we will discuss more problem. I will pick your doubts. We will solve it together. Okay. So, what was the Riemannian integration? So it is fx, a function. Okay. And suppose we have to check suppose this is our function, right? This is our function. Okay. And we have to check we have to calculate the area bounded by the function fx. This is some interval a to b, and we have to check area of this one. Okay. So earlier, there was no particular formula to do that, but always we know how to calculate the area for a rectangle, for a triangle, for a square, and that's it, right? So what we wanted to do, we just wanted to use this basic thing which was already known to all of us, right? So we defined a set P called partition. So this partition will contain some point x2 ... xn, which are in this interval AB. Okay. In this closed and bounded interval AB. So these were some point in this interval. Okay. Fine. Then, so let me draw it again. Okay. So these were our curve. Suppose we have a partition P, which is x1, x2, xn. This. Suppose let us now consider it is x1 ... x4. Okay. Then we can make a better understanding. So this is x1, this is x2, this is x3, and this is x4. Okay. Then what was our first thing? And okay, it was a equals to x0 and b equals to x5. So let us take from x0 to x5. Okay.
Yes, ma'am.
Yeah. So here we can take, this is our x0, right? And this is our f of x0, right?
Yes, ma'am.
This is our x1, it was our f of x1, right?
Yes, ma'am.
This is our f of x2, f of x3, and so on, right?
Okay.
Okay, and this was our f of x5. Okay. Then we take these lines, and we just draw some rectangles with the help of this partition. Okay. So if we calculate the area of each rectangle and then we simply just do the addition, then we will get some area, right? But there is some error. The yellow shaded portion is the error one, right?
Yes, ma'am.
Yes.
So this is not not same as the area of the curve, right?
Yes, ma'am.
Yeah. So what can we do next? We just take another partition P1 with more points. Okay. Suppose x7, up to x7. The previous one was up to x5 and the new one is up to x7. Okay.
Yes, ma'am.
Suppose here is some point, here is one point, x6, and here is one point, x7. Okay. Then we can draw two more rectangles, right? Like that. Right?
Yes, ma'am.
Yeah. So then what will be the what will be our new set of rectangles? One is this. It was. Second one is this. Third one is this. Right?
Yes, ma'am.
And fourth one was this. One was this. Sixth one was this, and seventh one was this. Okay. So
Yes,
here we can note that this was the error portion earlier, right? Which is
Correct.
no more error right now. This green shaded one, right? We can exclude some error. This was error in the earlier thing, but this is no more a error, right?
Yes,
Yes,
ma'am.
ma'am.
So when we increase the number of element in our partition, then we check that the error become lesser than the earlier one. Okay. So
Yes,
this
ma'am.
now became our idea to calculate the more appropriate area bounded by the curve. Okay. We can
Ma'am,
again, yeah.
the green shaded area error is like minimized
It
or
was
it is
error.
removed.
Yeah. It was error in the previous case when we took the partition as P. Okay. But as
Now
we
we remove
increase
it.
the number of points here, this portion got removed. Okay.
Okay, ma'am.
We increased our accuracy.
Yeah, we increased our accuracy here. Okay. So then what we can do next? We can increase more power. Here we can increase, like add one x8. Then again it will be something like that, right? So this portion will be again excluded. This error portion will be again excluded, right? So that is how we can increase our accuracy to calculate the area of the like bounded by the curve. Okay. So we note that like as we increase the number of element in the partition, we will get more accurate area. So what is the maximum number we can take in the partition? What is the maximum cardinality?
We can push it to infinity.
Yeah. So we push the cardinality to infinity, right? Yeah. So we push the cardinality to infinity. That means P, in the set P, we have xi such that I equals to 0 to infinity, right? Then we are just calculating area of each rectangles and then we were adding them, right? So we will add each of rectangles from 0 to infinity, and now we need the area of each rectangle, right?
Yes, ma'am.
Area of each rectangle. So what is the formula for area of rectangle? It's length into height, right? Length into height, right?
Yes, ma'am.
So if we look at one rectangle, the length will be here the length, this is x8, right? And this is x0. So here the length will be x8 minus x0, right? If we do this in sequence, like x0, then x1 and so on, so the length will be xi plus 1 minus xi, right? I equals to
Yes,
0
ma'am.
to, yeah. So we can denote this as delta xi, okay? So this is the length of the rectangle. Now what is the height? This is the height, right? For the first
Yes, ma'am.
rectangle, this is the height. This is our first rectangle. So the height is f of x0, right? That means f of xi for each I, right? Here it is f of x0, here it is f of x8 and so on, right?
Yes, ma'am.
So the area become f of xi into del of xi. That means height into length of the rectangle, okay? So this will become now I equals to 0 to infinity area of each rectangle. Okay.
Okay,
And then
ma'am.
we know that it will be equals to integration a to b f of x dx.
Okay. Okay.
Yeah.
Okay,
So
ma'am.
this is what we did in our basic Riemannian integration. Okay. This
So
was
like
the
this
basic
Riemann sum
concept of
ultimately
Riemannian.
gives the,
Yes.
like ma'am, this Riemann sum ultimately gives the definite integral.
Yeah. Yes.
Okay. Okay.
When the cardinality of p was tending to infinity, then we will get the definite integral. Okay.
Okay, ma'am.
Okay, ma'am.
So there is
And we will
huge
consider average
number
value
of
for this Riemann.
theory behind these things, but right now you just need to remind this basic thing, just this 2 and 3 steps. Okay.
Ma'am,
Ma'am,
Yeah.
will we
and
be
here
provided with the fx in the question? The
What?
common fx. Will we be provided with the general formula of the graph so
Yeah.
that we
They
can
will.
integrate?
Yes, for sure. You will get the general formula of the graph. Otherwise, how can I calculate the area bounded by the graph if the graph is something unknown, right?
Okay, ma'am.
So you will get.
total
Ma'am,
area
graph will not be given, ma'am. Simply interval will be given on the function value.
No, the graph should be given in
What
the
is the
case.
need of graph, ma'am? Just make the
You
subintervals
need
and
the
put the.
graph, right? You need the graph in order to check f of xi. You need the equation. I mean, graph I mean equation of the function.
Yeah, that's what I'm saying.
function.
Yeah,
Equation of
yes,
function will
yes. Not the graph. I'm sorry, it's my fault. The equation of the function will be given, and you just need equation of the function. Okay.
Ma'am, like if the equation of the function is given, so we can directly use the definite integral, right? Why
Yeah,
we'll go
you
for
can,
Riemann sum?
Like,
because
ma'am,
there may
I
be
have
question
pasted a
No,
question
which
there.
need this type of
it will
concept,
give a
right?
wrong answer.
Yeah, there
If you
we
direct.
don't have any equation and we are just given interval. Then how to get that?
Okay, let me check the question.
Average
Then
of
only I
right
can
Riemann
answer.
and ma'am, it will be average of right Riemann and Riemann to give
No.
the area of the.
Okay, if the graph is not given in the question, then maybe there is another way to do the solve the question. Maybe there are many tricks, but if the question is something like that, you have given a graph and you have to find the area bounded by the graph. Then the equation of the equation of the function will be given there. You need not to be worried about it. Always the equation of the function will be given there. Okay.
Yes,
Ma'am,
ma'am.
I have pasted a question, ma'am. It is there in the mock. Their equation is not given. Only interval is given.
Okay, this is a question for mock, right? So
Yeah.
what I suggest you that let's not discuss the mock questions because you will have some another session for mock discussion. Okay. So
Ma'am,
we can
already.
discuss something other than those questions here.
Yes, ma'am. Ma'am, what
Yeah,
kind of
so-
a specific question we can possibly
Yeah.
expect from this Riemann sum?
All concepts, ma'am, just go through, ma'am.
Yeah, this is the basic concept. This is I guess this is enough. If you know this basic concept, it is enough to understand this. And the question, I guess it will be something like that. It will be providing a graph and you have to check the area. You have to calculate the area bounded by the graph. Otherwise, you can have to do something using the rectangles. Okay.
Ma'am, what questions he just posted of the mock, ma'am? I've solved entire mock paper, ma'am. Even
Mhm.
I think that this question you should look in this question. Either the graph is missing or something. I feel like it is missing over there because I'm not
Okay.
even I was not able to make any as first
Okay.
two option can be. Mhm. Okay, go on.
Yeah. You tell me what are you.
I was only able to decide that first two options will be incorrect estimated area Because neither the graph is given nor the equation is given. Just they are asking to estimate an area.
Okay.
Can you please look
Okay,
at the
if you
question?
have something like that, then obviously there will be some different idea to solve that. After looking the question, we can do that. But I'm not doing this because we will have a mock discussion session, probably in
All right.
this
All right.
upcoming Friday. Okay. So you
Okay.
can do that in this Friday. So there is no like meaning to waste extra time, right? So if you have any doubt other than this mock paper, you can ask. Because this will be again we are discussing this mock papers, okay, in this upcoming Friday.
Okay,
So
ma'am.
you will
Go
get your
ahead.
answer. No problem. You will get your answer. So if you have any another problem with this Riemannian sum, except the mock papers, then you can ask.
Ma'am, actually, I'm not like getting what kind of question we can expect from this Riemann sum. Like the questions will be.
What I will suggest you to follow the activity questions and your problem like practice assignments and graded assignments. The question will be similar kind, okay? There will be nothing new during the examination. There will be the question all will be common, but you already solved in this like assignment question or practice problem or what, okay?
Okay,
Yes,
ma'am.
ma'am.
Okay.
Yeah. So don't worry about this question. You will get the answer. There will be one mock discussion and we will definitely discuss this question during this mock discussion session.
Okay, fine.
Sure, ma'am.
Yeah.
Okay.
Okay. So far we covered limit of a sequence, limit of a function, continuity, differentiability, and Riemannian integration. So if you have any doubt, you can ask it. If not, then we can stop. Otherwise, you can ask.
Can you please solve that electricity question sets?
Can we
Which
discuss some
this,
questions, ma'am?
Okay, ma'am.
Yeah,
So
just
this
for
is
this
10 for the
continuity and
calculus.
differentiability and integration.
Can you repost it? I just want to check it. Which I discussed some problem. If you were able to like solve these problems, then it is enough to do good in the examination. Okay. So you just try to solve this type of problem, which I already discussed in this session.
Okay, ma'am.
Okay.
Yeah.
Ma'am, this was like the theory part done for the calculus part.
Yeah. Yeah.
Okay, ma'am. Then. Ma'am, I had one doubt from the domain of the composite function.
Okay.
So, can you bring it?
Mm-hmm.
Yes, ma'am. So,
Domain, like if
yeah.
we have domain of the composite function is simple logic. If we have a from A to B and G from C to D, okay.
Okay.
So we want to do this F compose G, okay? F compose Gx. So first of all, this is defined as F of Gx, right? So we are applying F over, we are applying G over X, right? So the
yes,
first condition is X should be in the domain of G. Otherwise, this may not be something valid, right? This is first one. And then we are applying Gx over, we are applying F over Gx, right? So the second condition is Gx belongs to the domain of F. That means D should be subset of A. This was the condition. Now you can define your domain in like with this condition.
Like, ma'am, I was attending the previous session and I don't know who did that, but there I got to know that in order to find the domain of a composite function, like ma'am suggested that don't find the composition of a function first, and then don't go with this approach of finding the composition of the function first and then going to find the domain. You should find the domain separately of each and like both function fx and gx.
Yeah, you should first know the domain of both the function, right? Otherwise, you cannot apply these things. You have to apply this thing. So for that, you need to know the domain of both this function. And then only you can like verify whether it is defining in this domain, the function is defining in this domain or not.
Like this thing that ma'am told that if you want to find the domain of f of g, then the domain of f of g will be equals to the domain of g minus all those points for which gx does not belong to domain of f.
Yeah, it's same, right?
On this one, I couldn't understand. If you could elaborate that.
No, these things are same, right? We're doing this. That means like domain of F compose G should be like this element should belongs to C and Gx such that D D is subset of A. G of X such that G of X belongs to A, right? So these things are same. You can do it in this way and that way. These things are similar.
Ma'am,
If you
a single
understand
example.
one, okay, so simply let if from
Ma'am, D should be subset of A or subset of B?
Subset of A, because Gx in A, right? From here we are applying this. Gx belongs to A, domain of F. Okay, and D was the codomain of G. Fine. That means Gx belongs to D, right? And this implies Gx belongs to A. That means D should be subset of A. This is the condition. Okay.
Oh, yes, ma'am.
Yeah. So suppose if is from R to R positive, x goes to some x squared, and G is some zero one to R. X was going to root x. Okay.
Okay, ma'am.
So what is our F compose G? We want to find the domain for F compose G, right?
Yes, ma'am.
So that means the first condition, according to this first condition, the X should belongs to domain of G. That means 0, 1. Okay. Now we can restrict it in more, such that D is subset of A. So what is F of X? Sorry, what is G of X? It's root X, right? So what is the range? What is the range?
Ma'am, range of g of x,
It is
x should be
again 0, 1, right?
greater than or equal to 0. Yes,
The range is again 0, 1, right?
yes, ma'am.
We can even take this is the close interval.
Oh, ma'am, like
So this is clearly subset of real number, right? So we can take this as the domain of this composite function.
ma'am, like this gx, the domain of gx, like the range of gx, should be 0 to infinite, positive infinite, right?
No, we are taking the domain as 0 to 1, right?
Ma'am, I'm talking about, okay, ma'am. Okay. The range will be 0 to
The
infinite.
range will be again 0 to 1. G
Ma'am,
of
why
0 means root over 0, which is 0, and G of 1 is root over 1, right? That is 1.
Oh, okay, ma'am. Now got it.
Yeah.
Ma'am, I have a doubt in activity in 9.3, question number 10.
So you can take the screenshot, you post the problem.
Just a second, ma'am.
Yeah.
Ma'am, just one question, ma'am.
Mhm.
For this Riemann integral, ma'am, is it possible that we will get like divide into n subintervals and then find the Riemann sum?
Yeah, yeah.
Hmm?
Yes, it's possible.
Because I mean, mock there is a question.
Yeah. You need to know about this concept. That is why it's possible to get some question like that. There may be an interval given. Then they may ask, like they may mention the cardinality of the partition. Then they may be like asked to calculate you the area with this partition, with this formula, infinite this.
Okay.
Sorry to interrupt this one by question. Is there any
I cannot hear you. Can you come closer to the mic?
Ma'am, could you hear me now? Ma'am, could you hear me now? Hello.
Sorry, I cannot hear you actually.
Ma'am, I've sent the image in chat box
Yeah,
for question 10.
Could you hear me now? Ma'am?
check it. Someone is saying something actually. I don't know why I cannot hear you properly. Is it
Even we can
happening?
also not hear, ma'am.
Yeah. So it may be your mic problem.
Ma'am, could you take in like a question on this Riemann integral? You have
Yeah, sure. If you have doubt with any question, you post it, except the mock discussion session, because you will have some mock discussion session. We can discuss it.
Ma'am, can you please explain this composite function solution again, ma'am? I couldn't get it, ma'am. I really get confused between domain and range.
So, what is your problem? Specifically, you tell me what is your problem in like.
Ma'am,
in which
while computing the range and domain, ma'am, I really get confused. Let's say, for example, if I want to get the domain for the composition f of g, I'm not able to get to the exact answer, ma'am.
you need to be confirmed about the domain of the function g. Okay.
Okay.
Then you need to calculate the range. Okay.
Ma'am, range of g of x. Okay.
Yes.
The value of g
Range
of
of
x.
g. Range of g. Okay.
Yeah.
Then you need to check whether the range of G is subset of A or not. If it is not subset of A, then you need to restrict the range and the domain in such a way such that it become a subset of domain of F. Okay.
Ma'am, in step 1, what we did was we checked that x belongs to the
First, first it is necessary that X should be in the domain of X should be in the domain of G. Okay. Otherwise,
ma'am.
G of X cannot be defined. Okay.
Right, ma'am. And
So
step 2?
this is your first step. Then you need to calculate the range. If the range is already a subset of the domain of F, then we are done. Okay.
You mean to say range of G is already a subset of domain of F?
If range of G is subset of domain of F, then we are done. Okay.
Okay, ma'am.
If not.
Okay, else.
If not, then restrict the domain of F such that this hold. Okay.
And ma'am, what if we calculate that f of g complete function first, and then we try to find the the domain, then what will happen?
Yeah, that is what we can also do. We can compute f of g. F of g. Then we will get some function, right? And for the function, we can find the domain. And you have to keep in your mind this formula. Okay, using the help of this formula, and you can compute the function. Then you will get the domain. You can
So, ma'am, if I'll
calculate
take
domain for any random function, right? And if compose G is again a function, so you can also calculate the domain for f compose G and similar.
okay, ma'am.
Ma'am, can you able to solve one example for the composite function, ma'am? It's really collapsing, ma'am.
Yeah, please. Do you have any?
Ma'am, I've sent the question in chat box.
I cannot see anything with the composition function.
No, ma'am, actually, I have a doubt in activity 9.3.
Okay. Yeah, we will come to this later. There are many who are facing difficulties with the domain of the composition function. So let me do this first. Then I will
Okay,
come
ma'am.
to your doubt. Okay.
Okay, sure.
Ma'am, can we take the same example? Fx is equal to x root x and gx is x square or whatever it was.
That means you want to do me the
Ma'am,
decomposition,
please do it stepwise, ma'am. I am really not getting it.
Nothing, right? Okay. If
Ma'am, we
is-
will have a graph theory class on Thursday, ma'am.
Yeah, probably.
Ma'am,
On Thursday there will be the graph theory class. Yeah.
same time only, 8 to 10.
Yeah. I guess the timing is also same.
Okay, ma'am.
Yeah. So from 0 to infinity, x was going to x square. Okay. And g was from 0 to 1. 0 to 1. X was going to x. Okay. Suppose we want to find G compose F. Okay. So our first step is X should be in the domain of F. Okay.
Ma'am, I have sent a questions on a composite function, ma'am. Just now I posted.
Let me do this, then I will pick this one. Okay.
Okay, ma'am. Okay.
This is our first condition that X belongs to R, means domain of F. Okay. Now we have to check that we have to restrict the domain in such a way such that range of A, F becomes subset of 0, 1. That means domain of G. This is the second step. This is the first step. This is the second step. Okay. So what is range of F? Range of F is 0, infinity, right? So clearly this is not subset of 0, 1, right? 0, infinity is not a subset of 0, 1. So we need to restrict our domain in such a way such that this become a subset of this 0, 1. Okay. So what we can do, we can restrict the domain to +1 to -1. Fine. Then if we apply F over there, +1 to -1. Okay. Then it will be 0 to 1, right? Subset of the domain of the function F. Okay. So we can take this as our domain of G compose F. Is it clear now?
Ma'am, for G of F, ma'am, we checked for the range of F to be subset of domain of G. Correct, ma'am?
Yes.
Ma'am, in the next step, what you have done, ma'am?
We restricted the domain of F in such a way because see, here this condition is not holding, right?
Right,
because
ma'am.
Range of F is 0, infinity. It's not a subset of 0, 1, right?
Correct, ma'am.
So we need to restrict the domain of F in such a way such that range of F become a subset of domain of G. Clear?
Okay, so we are restricting the domain of F.
Yeah.
Okay.
In such a way that range of F become a subset of domain of G.
Okay, ma'am. Okay, ma'am.
Now we got it?
Yes, ma'am.
Ma'am, sorry to interrupt. This calculus completed, ma'am.
Yeah.
Okay, ma'am. Will you share any questions?
I don't have any question in my mind. I solved some example. Now, if you have something, we can solve it.
Okay, ma'am. Thank you, ma'am.
So here there is one example that X is G of X is 1 by X%. So whoever facing some problem with the domain thing can unmute yourself and please, what will be the domain for F? What will be the
Every
domain?
real number except 4.
Yeah, all real number except 4.
Except 4, yes.
Except 4 all real numbers.
Right? And what will be
Yes.
the range?
Range is all real numbers.
Real number except 1.
Except 1.
Minus infinity to infinity.
So are you sure it's a whole real number?
1 minute, ma'am.
So what is the range? X minus -1, right?
Yes, ma'am.
And the range is R, right? Correct?
Yes.
So
Yes,
what will
ma'am.
be the domain for F compose GX? According to our first problem, that X should be in the domain of G, right?
Yeah.
Right? And the range of G, we need to check that the range of G should be subset of domain of F. That means it should be subset of R minus 4, right? Right?
Yes, ma'am.
This should
Yes.
hold. This should hold, right? But here the range is R, which is not a subset of R minus 4, right? So what we need to do, we need to remove this point from the domain of G for which the image of G was 4. Okay?
Ma'am, the range of f of x is except 1, ma'am.
G of X is except -1.
Or f of x, the range.
Okay? Is it fine now? So we need to adjust the domain of F in such a way such that the range of G become a subset of domain of F. That means R minus 4. That means we will exclude the point for which the image is 4. Okay. Suppose for some X, the image of G is 4. Okay. Then what will be the value of X?
Ma'am, it's coming out to be -3/4.
So X will be -3/4, right? Now, if we simply exclude this point from the domain of G, that means if we take domain as -1 -3/4, then we will not get -4 as the image of any point in this domain, right?
Yeah, yes.
We can restrict the domain such a way, then G of X equals to 4. There doesn't exist any X such that G of X equals to 4, right? That will imply that range of G will become subset of R minus 4. So this will be the domain of this composite function. Is it now clear to all of you?
Yes, ma'am.
Yeah, ma'am. One thing, can you go in that way, like first find f of g of x and then find the domain? Can you do that?
Sometimes there may be some difficult function, okay? Not every time you will be like able to calculate the function. So better if you can do this simple step. If you have some simple function, then you can calculate the function and then you can check the domain, okay? If you have some difficult function, then it will take so much time if you go like if you calculate the function, then if you determine the domain. So it's better to do some logical steps and calculate the domain like this, okay?
Yeah, okay.
Yeah, only one thing you have to do, you have to do this logical step. You have to follow this step, nothing more than that. Am I clear with these things?
Yeah, ma'am.
Yes, ma'am. Ma'am, hello.
Yes.
Ma'am, actually, this video is very important, and I don't know exactly from where to get. I know there is a sheet maintained for maths, but I'm not sure whether the link for this video would be provided over there.
What I will suggest, you can directly go to the YouTube channel, which is IITM BS degree. Okay. Then we will go to the live section.
Okay, ma'am.
You will find all the instructor session there.
Okay, ma'am. Thank you, ma'am.
But in the
Ma'am,
YouTube
like,
channel, the TA sessions aren't available.
Yeah, the TA sessions may not be available, but all the instructor
It is available in
sessions
G
are
sheet.
Yeah, this it.
Yeah.
ma'am,
Yeah.
like PDF of this session, how we can get that?
If you want PDF of this session, I will share it in the chat box.
Yeah, ma'am, please share it.
Yeah, I will share it.
Okay, ma'am.
Okay, give me some minute. I will share this PDF.
Oh, sure, ma'am.
Just wait for some minute. I'm sharing.
Ma'am, there's a PDF.
Yeah, please wait for some minute. I'm sending the PDF. I have to make the PDF, then I can send it. Can you check? Are you able to see this?
Yes, ma'am.
Like whether it is clear or not? Can you check? I mean, not in the
Yes, ma'am.
screen, in the chat box.
Yes, wait.
Yes,
So
ma'am, it's clear.
is in image format. So are you
Oh, yeah.
able to see the image?
Yeah, we can.
Oh,
Ma'am, but we can't zoom it.
it's not
Ma'am,
clear
It
in
is
my.
quite pixelated.
Yeah, ma'am, it's blurry in my phone.
Okay. It's
For
clear.
me, it's clear.
Can you
Like
make the
this.
PDF of this, ma'am?
Yeah. Can you check it whether you received it or not?
Not yet, ma'am.
Yes, ma'am, not yet.
Okay, let me share with you. So if you have any doubt and some question, you can post it.
Can you explain Riemann sums?
No.
I just explained it, right?
Yes, ma'am, you explained it already.
Yeah, I explained it already. If you missed this portion, you can find the video on the YouTube channel. You can have a look there, okay?
Okay, ma'am.
Ma'am, this one is not streaming in YouTube.
No, this is being streaming in YouTube. You will find this on the YouTube for sure.
Yes, ma'am, it's streaming. Someone has sent the link. You can check.
Yeah, I think there is a link in the chat box. You can find it. Yeah, I got the PDF. Let me
Okay.
share. Are you able to see the PDF now?
Oh,
Yes,
yes,
ma'am.
ma'am. Oh, I got it.
So it was the calculus portion. I guess we can stop this session, right?
Oh, sure, ma'am.
Yes, ma'am.
Okay, ma'am.
Thank you, ma'am.
Thank you, ma'am.
Bye, ma'am.
Thank you, ma'am.
Thank you, ma'am.
Thank you, ma'am.
Thank you, ma'am.
Good night, ma'am.
Thanks, ma'am.
Thank you.
Thank you, ma'am.
Thanks.
Hello. Am I audible? Hello. Hello. Is this session end?
Yes, and leave.
Okay. It start at 8 p.m. now? Hello, sir. Are you in the meeting?